Hi everybody, today we are going to talk about 12.4, analyzing data sets. So we are going to find the population standard deviation from data set and compare them. So what is population standard deviation? So the standard deviation is a measure of the spread of scores within a set of data. So how the data spread from the, is usually from the mean. So we are usually interested in the standard deviation of population, but you will see there is another standard deviation of a sample, but don't worry about the sample standard deviation. So we'll focus on the population standard deviation. So this is the formula. This we call it sigma, but this symbol also sigma. I mean that this symbol also sigma, but don't worry about it. This symbol is population standard deviation. How do we get it? Square root. Inside the square root, this symbol we learned it before. It means sum, right? You are going to add all the data. But now, so which data you are going to add it? In the parentheses, x minus mean. This is mean, right? So individual data minus mean. So you subtract mean and then square it. And the squares, you should add them all and divide by number of data. And we should do square root. That is a population standard deviation formula. I remember when I was in high school, we calculated everything manually, so without using the calculator. At that time, we didn't even have a TI-84, that kind of calculator. But now you guys are very lucky. You don't need to do this manually, right? So let's say we have a data 58, 63, 68, 69, 75, 66, 65. You know how to find the mean, right? You are going to add everything and divide by how many numbers? 7. That's the mean. But you have a TI-84, you can put everything and then you can get the mean, you can get the sum, you can get the population standard deviation. We did it before, so if all the information for box whisker plot also, right? So how do we do it? Let's do it together one more time. So we follow this step. Stat, go to the edit, and put all the data in L1. And then go to the stat again, and then click the first variable, stats, in the and then calculate. That's the steps. So let's do it together. So now I will open the calculator and step button is here, right? Stat, edit. So we do the edit. So number 1, edit. I already entered all the numbers 1, 2, 3, 4, 5, 6, 7 data, right? 7 scores. So after that, what do you do? We are done in L1. We use the L1, right? If you put all this data in L2, you need to change to the L2 later. But we are using L1 now. And then what is next? Now you entered all the data. So it's ready in the calculator. So we should get the mean, sum, and standard population standard deviation. But now what do? You just click. Let's follow the second step. Stat, here's a stat. And then what is next? First variable stat. Where is it? You should move to the calc here. So how do you move? Move here. Then do you see the first one? That's the first variable stat. So you click number 1, first variable stat. List. all the data is in the L1, right? So you need to check this L1. If you put enter all the data in the L2, then you need to change it to L2. But usually we use L1. Frequency list. In the last lesson, when you have a frequency table, you use this one. But now we have only L1. There is no frequency. Then just skip it and go to the calculate. So we are going to just enter, do nothing, and just enter. Voila. You got everything you need. So what is this? This is the mean, right? 66.29. And what is this? This is the sum of all the data. X means individual data, right? So every data you should add sum, then you get the 464. What does it mean? Square of all the data, and then you add them all, right? Sum of all the squares will be 30,924. This is SX is a sample standard deviation 5.28, but we are going to use this one. Population standard deviation 4.89, n equal to 7. It means you have a 7 data, 7 scores, and minimum was 58. First quartile is 63. If you keep going down, median is 66. Third quartile 69. Maximum 75. You remember how to get this right? Now, let's move on. So, standard deviation is a number used to tell how measurements for a group are spread out from the average or expected value. You should understand what it means. When you get the standard deviation, you can see how the measurements, the scores are spread out from the mean, from the average, right? So low standard deviation means most of the numbers are very close to each other, to the average. High standard deviation means they are very, the numbers are most spread out very wide. Okay. So this number one, we already got the mean and standard deviation in the calculator just now, but there's a second set. We want to compare them, right? So we already did. We got this one, 6.29, and then this one standard deviation, population standard deviation 4.89. Now, how about the second set? If you do the same steps as we did it just before for this first data set, you will get mean is 66.29. Oh, this same mean, right? The mean averages are the same. But what is different? Standard deviation is different. This is a 4.89, but this is what? 20.04. Look at the data. So what do you notice? What do you notice? Look, even though just by looking, you can tell they are very close each other, but these scores are very far each other, right? Minimum value is 58, maximum is 75, but minimum is 35, maximum is 100, but their mean is same. Now, how can we interpret this with this standard deviation? So if you look at the data, now if you put all the data in the number line, it will be like this, right? So 7 data, look at this. They all stay very close each other. But this one, second set is, your mean is here, but now 35, and then 52, 55, 70, 85. and this is 100, and this is 67. Do you notice something? This is all very stay close each other. This is stay far from each other, right? So conclusion, both sets have the same average. However, the scores of the first set is closer to the mean, and the scores of the second set are more spread out. So you understand how we use a population standard deviation, right? So today's lesson is this. Okay, we stop here.